Hello, I'm Zooko. How many people here are from Seoul? Will you raise your hand? And how many people here are from somewhere else? I was trying to spot somebody who didn't raise their hand either time, but I think everyone raised their hand one time. So good job. You're all paying attention. Will you change the slide? Let's see. Oh man, this could be hard to keep telling you to change the slides back and forth, June. Okay, this is about Zcash. Next slide. This is our motive. Our goal is to empower everyone in the world with economic freedom and opportunity. And I always thought forever that encryption was going to be an important part of that. Even before Bitcoin, I worked on encryption for the internet for the same reason. And I still think that encryption is going to turn out to be a necessary component of empowering everyone in the world with economic freedom and opportunity. Oh yeah, by the way, I don't speak Korean, so if you have trouble understanding English, you should sit next to someone who can translate for you and ask them, what did he say? What did he say? Okay, next. Okay, so yeah, we got started on this because there were a bunch of scientists who, like before Zcash was founded, before the company I founded existed, there were a bunch of scientists from various research institutions, Johns Hopkins and Technion and MIT and Berkeley and others, and they came up with a new cryptographic scientific breakthrough which allowed the combination of encryption with blockchains. Next. We'll skip this one. What? Oh yeah, okay. Wait, skip this slide. I don't like this slide very much. That's a good slide, but don't read it yet. Hold on. Go back to the other slide or something. No, that one's got too many words. Go back to the previous slide. Okay, leave it there. Everyone's already read that one. Okay, so I want you to interrupt me and ask questions. And so we brought some t-shirts, but we don't have enough to go around. And whoever, because I was told that Korean people are shy. So especially if you're shy or if you're Korean, then if you interrupt and raise your hand and ask me a question during my talk, then Josh will give you a special shirt. Okay. All right, next slide. Next. Okay, yeah. Like I alluded to the early days of the internet when HTTP was invented in the 1990s, you know, the World Wide Web was invented. It didn't have encryption built in, so whenever you connected to a website, then any hacker in the middle would be able to see what you were doing. First name equals Zooko, credit card number, account number, amount. All that was visible to unauthorized parties. And the solution to that was to add encryption, which Netscape pioneered in 1994. And now, if you are using HTTPS, then whenever a user connects to a website, any unauthorized party in the middle only gets to see ciphertext. They don't get to see any information about the user. That's the way encryption works. And I was working in the internet industry at the time in the 1990s, and one interesting thing is that during the first few years, this HTTPS stuff, it was considered to be special. It was inefficient, and so people wouldn't use it on all websites, and it was considered to be kind of controversial. Like there was a faction inside the United States government that tried to prevent HTTPS from getting deployed. You might not know this. It's one of these strange but true facts. For years and years, for maybe 10 years, they tried all kinds of techniques to either outlaw or subvert or confine how HTTPS could be used, because they were afraid that encryption would undermine law enforcement and destabilize society, and encryption could be used for criminals and stuff like that. And what I think is really interesting about this story, and I wish more people knew the history, because 10 years later, governments, all governments, including the United States, were requiring HTTPS, because HTTPS protects your users from having their private information exploited by hackers and thieves and foreign governments. So no government today would allow their citizens to use HTTP, because that would just be making your infrastructure accessible to foreign enemies. So there's a complete change, a complete conversion of the public perception with regard to HTTP over the last 25 or however many years that is. Okay. So what we've been working on is the equivalent for blockchain. This is Bitcoin, and whenever a user makes transactions of any kind, smart contracts in Ethereum, or transactions in Bitcoin, or any of the other things that you might be able to do with a blockchain, if it's this kind of unencrypted blockchain, then all sorts of unauthorized parties get to see details about the user's activities. And what those scientists had come up with a few years ago, those ones who worked at MIT and all that, they came up with a technology with which you can encrypt the data that goes into the blockchain, so that the authorized parties that are supposed to see this data get to see the transaction like any blockchain, but unauthorized parties see nothing, just like with HTTPS. All right, how many people have ever looked at a Bitcoin block explorer? Okay, how many people have never looked at a Bitcoin block explorer? Did you not raise your hand for either one? Oh, okay, you've already looked at one, okay. All right, so this is what it looks like. And you can just go to, like, not right now, because you'll get distracted, but after the talk, you can just search for Bitcoin Block Explorer, and you can see all this information about other people's transactions. And it doesn't look like much, because you don't, this doesn't, it looks like you're not seeing any private information about other people's stuff, because it's not got their real name in there or their home address. It's just got these random addresses, right? And this is kind of like in the very, very early days of the internet, because internet addresses are just 4 numbers with dots in between them. People thought the internet was private, but now we know there's a lot more to it than that. Computers and machine learning can deduce a whole bunch of facts about your private behavior from this kind of data. Next. This is what it looks like if you go search for a Zcash block explorer. Well, it's more complicated than this, but this is a simplified view of it. So the block number is still publicly known, and the timestamp is still publicly known, but the sender, the recipient, and the amount transferred, and also there's another field that it's not shown here, but there's a memo that you can include, so you can include a message which is only visible to the intended recipient and not visible to anyone else. Maybe I should raise the price and give out 2 shirts to the first person who interrupts and asks a question. Does anybody have any questions yet? No. Okay. Next. Okay, so now here's a complicated. This is the first part of the complexity of Zcash that I have to get into now. Everything I've said before is the simplified version, how I would like it to be. But in practice, when we designed Zcash, we came to this point about 4 years ago now, when we had designed the encrypted transactions, and then we said, shall we also add support for unencrypted transactions in addition to encrypted transactions? And the reason not to add support is that 2 things is way more complicated than 1 thing. And you don't really need plain text for anything. You can do everything with ciphertext, because you can reveal the contents to the right parties. And I'll get to that later. But the reason to include the unencrypted behavior is for backwards compatibility with Bitcoin software. So we figured if we make it as easy as possible for all Bitcoin companies to add Zcash support, that'll make a big difference. And it has. So it was probably worth it that we included the backwards compatibility, because almost every Bitcoin company has added support for Zcash, because it's really easy, because these addresses are just like Bitcoin addresses. The ones that start with a T, see how that starts with a T? These are called transparent addresses, or T addresses, and those ones are just like Bitcoin, and they don't give you any specific added privacy, but it's really easy for all the products and websites to support them. Now, if you look at the Zcash Block Explorer, this is what you actually see, is you'll see some transactions that show from this particular address to that particular address, a certain amount was transmitted, right? And then you'll see one that says, from this particular address to blank. And that's the difference between other blockchains and Zcash, is when you look at that Zcash Block Explorer, it'll say, it went from this address to blank. And that means nobody other than the recipient knows the address of the recipient, right? Like, the address of the recipient may never, it won't ever appear anywhere in the blockchain. So if you talk to someone and they gave you a business card with their address on it, you could see it, but it never appears in the blockchain. Next. Yeah, so I said we don't actually need transparent addresses for anything, because encrypted transactions are good enough for everything. And the reason I say that is that encryption comes with viewing keys. Encryption, if you're using encryption to protect data, that means there's a decryption key which reveals the data. Now, that means you can give that decryption key to anyone that you want them to see the data. So we call that a viewing key. In Bitcoin, there's a spending key, which I guess they call a private key in Bitcoin. What's the word in Bitcoin for the key you use to send your money? Private key. Okay. Well, I call that a spending key. And then there's addresses, and in Zcash there's also addresses, just like in Bitcoin. That's the thing you use to specify where you want the money to go. But then in Zcash there's a third thing, which is a viewing key, and that's the thing that allows you to reveal information in the blockchain, but doesn't allow you to spend any money. And every address has its own viewing key. Okay, next slide. So here are three different addresses. The encrypted, the shielded addresses in Zcash begin with a Z. So I call those Zatters, or Z addresses. And I said they never appear in the blockchain, but they're in the block. There's information in the blockchain, but only visible to the right parties. Yeah. That's a good question. The question is the viewing key tied to the public address of the sender, or yeah, or can you do it per transaction? That's a really good question, because you might not want to reveal all your transactions. You might want to just reveal one. And the answer is I don't have any slides that show this, but there is actually a way to have a viewing key for one specific transaction. There's two different kinds. So the one specific transaction we call a payment disclosure, I think is the terminology. So for example, you can use that as a receipt, right, to show you paid. You can reveal that payment in the blockchain without revealing anything else about your other transactions. Like if you deposit your money into an exchange and then they lose it, you can post that view key that shows your particular deposit without revealing your other ones. But these slides are all going to show the other kind of view key, which is associated with all the transactions of a given address. So ZSBZX received this many ZEC, and there was a memo field. ZSBZX can't see anything else because they weren't the sender or the receiver of anything else. This? What's the question? Yeah. Yeah, so like, yeah. Yeah. So this is an example of an actual address, ZSBZX. And if you use Zcash, you can like cut and paste this and send it to your friend, right? And then that's what they use to specify where the money should go, right? Now, all these other ones have an address inside there, but then it's encrypted. So, so if you look at the blockchain, you'll just see random bits. Yep. Can you go to a previous slide? So with transparent addresses, it starts with T. So anytime someone sends you a Zcash address and says, please send me the money here, you can look at that address and you can tell if it's a transparent or a shielded address that you would be sending to. That way. And then, like I say, these ones you can't see anything, right? This is encryption. Okay. All right. So yeah, stop. So ZSW4P is the recipient of this payment, and the recipient of this payment, and the recipient of ZSW4P is the sender of this payment, of this transaction. And so the sender can always see the recipient and the amount and the memo of what they sent, but the recipient doesn't see the sender. So you don't know who the sender is unless they put something in the memo field or they tell you. Next. So ZSSBJ received this payment. So they don't know who loves them. It might be a secret admirer if they don't tell, or it might be someone they know if the person tells. And this is funny, but I really love this because this has actually happened at least twice. 2 different people I know came to me and they said, I want to tell you something. I sent and received love notes in the Zcash blockchain. So Zcash is the first thing that is both it's a immutable, permanent blockchain. Like, you know, who knows what I mean about blockchains being immutable? Or like add only or whatever the word is. Like the blockchains have this property that you can add stuff to them, but you can't take stuff away, right? That's what's new and weird about Bitcoin and everything that came after Bitcoin is it's got that property that you can add to it, but you can't take away from it. Zcash combines that property, the add only property, or the immutable or whatever it's called, combines that with the privacy property that encryption gives you. So it's perfect for love notes because it's like carving your initials on a tree, but then only you and your lover can see it when you look at the tree, but everyone else can't see it. It's invisible to them. So I have not seen these love notes because I was neither the sender nor the recipient of the love notes, but 2 different people told me, and it wasn't sending to each other either. There were 2 2 couples. 2 different couples, one of each told me that they were sending love notes in the Zcash blockchain. I think that's pretty sweet. Okay, so. Wait. Okay, so I've been going around meeting with regulators and law enforcement agents and people like that. Remember how I said in the early days of the web, a small part of the United States government was afraid of encryption? Similarly, I'm afraid that some policymakers and regulators are afraid of encryption in blockchains. I've noticed that, no offense to any government people who are here, but I've noticed that government people are a decade or so behind the times, roughly. So we've been going around trying to educate them, and because the best antidote to fear is knowledge, so we've been going around educating regulators about how stuff works, like encryption. And this is my pitch to regulators, which is why you should require the cryptocurrency industry in your country to support encrypted blockchains. And it's like this: if the people in your country, so you're the government of South Korea, and if the South Koreans are using unencrypted blockchains like Bitcoin and Ethereum, then, well, there's a good thing about it, which is you'll be able to see the transactions they're making, right? Because it's a public open blockchain. But now, there's a different requirement that you have, which is you, as the government of South Korea, you really don't want the financial transactions of South Koreans being visible to the governments of France and Russia and the United States and North Korea and Japan and Brazil, right? And if they're using Bitcoin, everything they do on the Bitcoin blockchain is visible to all of those other agencies. So that's not great. And another thing you'd like is you don't want South Korean citizens' activities to be visible to just random unauthorized third parties, ex-boyfriends and ex-girlfriends, extortionists, business competitors, insurance companies, everyone else. A typical rule in financial regulation in well-organized countries is people's private financial data, you're required to show it to the government under certain conditions, you're required to use it for certain business purposes, and you're required not to allow anyone else to see it. It's like a law in every country. And Bitcoin violates that law. If you're a South Korean company and you've sent and received Bitcoin transactions with your customers, you're exposing your customers' private data to unauthorized third parties. Okay, what if instead the South Korean users log on to Binance in Malta? And what if Binance uses an encrypted blockchain like Zcash? Well, then you've got a problem. You won't be able to tell what the South Koreans are doing, right? Because Binance isn't located in South Korea. And if you look at the blockchain, you'll just see ciphertext, right? And this means the government of Malta can see what the South Koreans are doing, but the government of South Korea can't. That's not optimal. But at least all the ex-boyfriends and insurance companies and everyone else won't be able to see what they're doing. So, and then finally, what if you have a South Korean exchange and the South Korean people are using that and it's using encrypted blockchain? Now, the South Korean government can see what they're doing. Does that make sense? This is the one that this is the one that people were confused about. They thought, if my South Korean exchange starts using Zcash, then the South Korean government will no longer know what the South Korean people are doing on that exchange. And that's just not correct. Make sense? You guys are all looking really thoughtful. Is that because you're now confused, or was it because you were confused a minute ago and now it's clarified? Right, okay. The question is, Can you give him a Zcash T-shirt? The question, what? But answer the question. The question is that just because the exchange gives the government a special key or what? Okay, that's a really great question. And the answer is the special key helps. So the view key that we showed earlier, I didn't make it clear on the previous slide, but the view, you remember how, can you back up to the previous slide? You're going to have to hit back up like 12 times. So remember how the person like who sent this one can, well, this is a love note, so I don't think they want to share the view key. They don't want anyone else to see their love note. Maybe they do. Maybe they want to show their friend, like, oh, look what he sent me. So let's go back to that one. So if you want to show your friend your love note, you can reveal the view key to your friend, and that allows your friend to look at the blockchain and see the love note, and now they know like it's actually in the blockchain. It's like original, authentic, carved into a tree blockchain data. And now your friend can see it, but you can still see it, but nobody else other than your friend can see it. Okay, that's a view key. And it works for all the other data in the blockchain. You can expose it to a third party. You can selectively disclose it to a selected third party without disclosing it to unauthorized other parties. That's a view key. So now hit forward like 12 times. So there's two reasons why. Yep. Yeah, so let's use one of the non-love notes for Samsung versus Apple. This is not the message from Samsung to Apple. Go back. Okay, this one, 29 sec for a payment, right? ZSW4P can be the address of Apple. And it could have received this transaction in the blockchain. And now your question was, what if later the sender wants to reveal this transaction to a third party or to the public, and the recipient wishes they wouldn't? And the answer is the recipient can't prevent the sender from doing that. And that's just, that's not a design decision on the part of Zcash. That's just a consequence of mathematics. There's no way to give information to someone while preventing them from giving it to someone else with general purpose computers, as far as I know. Does that answer your question though? Was that the intent of your question? Okay, so yeah, if you send someone an invoice and they pay you through, if they send you cash, if they deliver cash to you, or they send you a bank transfer or whatever, they may later be able to show a third party some evidence like the invoice or a copy of the bank transaction or something, right? He says it's like a screenshot of a Snapchat. It might disappear, but you still have a screenshot. So if someone paid you, they might, by any means, by cash or a bank transfer or WeChat or whatever, they might be able to still show some evidence to claim that they paid you, and you might be able to deny it and say, oh, that you forged that screenshot, you never sent me the money, or whatever. And with Zcash, you don't have as much of a way to deny it, because if that's your address and everyone knows that's your address, then once they have the view key, they can see that your address received a payment in the blockchain, and since it's in the blockchain, it could not have been forged. So that's both good and bad, but that's the fact. Oh, that's a really good question. Unfortunately, the effective default is that it's not even just a default. Even worse than that, a lot of the wallets and exchanges and services out there don't support Z addresses at all. So you have to use T addresses to use them. If you have a wallet that supports Z addresses, then yes, you make a Z address and send all your money from your T address to your Z address and tell everyone to start using your Z address from now on. You can with a wallet that supports both kinds. In the same wallet, yeah. You can do that with the wallets that support both kinds. So that's a big change that I expect to happen in 2019 is I expect a bunch of wallets to support Z addresses so that it can become the default. But until now, T addresses have been the default. Let's see. Okay, so any more questions before I go back to where I was? That's a great counter argument, and let me finish this 3x3, and then I'll go back to that. You're basically kind of mostly right. Okay, so what I was saying was, this is the thing that people didn't think through, was that if a South Korean exchange supports Z addresses, then they're still going, the South Korean regulator and law enforcement and government is still going to have access to the information about what the customers of that exchange are doing on that exchange. And to his question, is that because the exchange shares a view key with the government? Well, they could, and that might be better for the government than the current way things are done. But the current way things are done is that the government sends you a fax that asks questions about your customers, and I guess you're supposed to fax back. View keys would be better than that. But even if you don't use view keys, you can also just send faxes back and forth and it has the same effect. It's just more likely to be wrong because it doesn't have a blockchain or fraudulent or slow and inconvenient. Does that make sense about how currently information sharing happens between companies? So this is definitely predates cryptocurrency, but all financial institutions in modern economies have to share information with law enforcement and regulators and government in different cases. And they do share that information, often literally by faxes. That wasn't even a joke. And the same kind of sharing works for this case, although the addition of view keys probably makes it better in a lot of ways for the exchange and the government. Oh yeah, so right. But if South Koreans are logging on to a South Korean exchange and using shielded addresses for their business, now the government of Malta and France and China and whatever don't see what the South Korean citizens are doing. And finally, everyone else on the internet doesn't see what they're doing. So my argument is, if you're the government of South Korea, you want this. You want to get a local exchange to support encrypted blockchains for the good of yourself and your country. The end. Oh, hey, now, did you say you run an exchange? You're in the exchange business? Do you mind telling me what exchange you work for? GoPax? Thanks for coming. So his statement was, if a customer withdraws money from an exchange, and then, is this what you, say it again. Yeah. Right. Right, so if a customer withdraws Zcash out of an exchange to their own wallet, And then they can send it to a Z address. Like it can be their own Z address, or it can be in a Z address of a merchant they're buying something from. And then the exchange doesn't have any visibility into what they did after they withdrew. That's true. And it could be it's arguably a problem. It's arguably not. It may be a trade-off. It's the same as the situation that financial institutions and exchanges have to do with cash. And it's very similar to that they have to do with bank transfers. So if you run an exchange or a financial, like a bank or a money services business or whatever, and a customer withdraws money out of their account, and what they do is they ask you to transmit that money to their account at another bank, then similarly you don't have any more visibility of what they did after that, right? You know which bank to tell. If law enforcement comes asking you what happened, you know which bank to tell law enforcement to go to next, but you don't have any other visibility. And then if it was cash, then you don't even know where to go to next. Correct. Yeah. So all of this is assuming that people never use local wallets, right? And that's like 99% true. So for the 1% of people who withdraw their Z address or who withdraw their crypto coins to a local wallet, then there should be like more rows or more columns on this. But the thing is that regulators, at least in the United States and in the UK and everywhere else that I've talked to regulators so far, none of them are contemplating rules controlling what people are allowed to do with their home computers. Like all of the, I mean, at least they never brought it up to me. All that they ever talk about is what rules to impose on exchanges. Like that's the way things are done in the United States in terms of financial regulation, is that financial regulation is regulation of banks, and nowadays of banks and Bitcoin exchanges. Does that make sense? That's just the way it works. So as far as what you want your exchange to do, this graph is correct. As far as whether you want your exchange to do this, that, or the other, this is the effect. Now, there's a different row or column, which is whether it's visible to you when people are using encrypted or unencrypted blockchains on their own personal wallet. It could. It's pretty much the same as cash. The only difference is it's easier to send it through the internet. So I actually don't think it's a serious problem. Like, all of the regulators in all of the modern countries can handle cash. But it could, either because sending it through the internet for like frictionlessly makes it worse, or because it's actually not worse, but but the regulators panic because it's new and scary, and so they think it's worse. Yeah, that's true. Yeah. That's true. It crosses borders easier. I mean, that's what's good about it. That's why it's better than the old kind of money. But I agree. It could be at least. How do I put this? I'm trying to be charitable here. I'm trying to give. I'm trying to say it's like it could be a valid concern. My honest opinion is that it's more like it's easier to pick on something that's new and has a small user base, and so you can sort of characterize its users as being weirdos, but objectively the mainstream things like banking services, wire transfers, physical cash, everything like that has probably 1,000 or 1,000,000 times the objective problems with crime and money laundering that any cryptocurrency has so far. Okay, so it could become a big problem if it got to be like 1,000,000 times bigger than it were today, and it turned out to be more of a problem. And I don't want to just poo-poo the idea. I think it's valid, but I think it's kind of overblown. Like it's not. It's hypothetical. Let me put it. It's speculative. Wait, what's the question? Do we create technology that makes the world have worse people? Oh. Well, you already, that's not a question, that's a comment, but you already got a shirt, so you don't care. So the comment is, the technology doesn't make people worse. It just could be used by bad people. But my argument's different, which is that bad people, like money laundering and bribing and all that stuff, it works really, really well. Like the cryptocurrency is not going to move the needle on that market. They're perfectly well served by the banks. The cryptocurrency is useful for people who can't get a banker to do their bidding, right? Because they're not rich. Anyway, next. Oh yeah, so I made this argument. To the regulator in New York. They're the most aggressive regulator in crypto because they came up with this thing called BitLicense a few years ago, which is a rule in New York that any company that wants to do anything with cryptocurrency that touches New York residents, they have to get permission from them first, which is way more heavy-handed and aggressive regulation than anywhere else. So we went to them first because they were so heavy-handed and forward-leaning, and made this argument to them about the protection of New Yorkers with the different kinds of technology. And rather to my surprise, they agreed, and they granted Zcash, they granted permission to their companies to list Zcash as one of like 10 or so coins, which is approved for listing in New York. And these are all the exchanges around the world that currently list Zcash. And you can see the New York ones, Gemini, Circle, and Coinbase, required permission from the New York regulator before they could add Zcash. They treat it the same. They treat it with their same AML KYC procedures as fiat deposits and as deposits in cryptocurrencies that Chainalysis doesn't support. Good question. Ooh, t-shirt? Did he already have a good t-shirt? I don't think he got a t-shirt yet. Next slide. I don't know what. Oh, yeah. Thanks to Corbett for hosting us and listing Zcash. Does GoPax list Zcash yet? Oh, yeah. Good. Thanks. Yeah. The end. Will you go back to the previous slide so everyone can admire all the lovely logos of our business helpers, allies? Okay. Good job asking lots of questions and using up our t-shirt stocks. Wait, is it really 8:23 already? I designed the Zcash logo myself.
I'm sorry, but just
5 years ago.
I mean, it's simple.
In between coding.
I think I don't know. It's just a question that I had.
Okay, the answer to your question is we have no plans right now to rebrand Zcash. Do we? He's in charge of that. No, we have no plans to rebrand Zcash, which is good because these T-shirts will still be good.
Okay.
I appreciate your question, seriously. Wait, wasn't there someone back there who had a question? Yeah, that guy. What? Are you gonna go help?
So theoretically, if a government makes a law that enforces someone to reveal his view key or whatever, so then what's the whole point? I mean, this is kind of. I don't think this is gonna happen, but we know what happened to Ether Delta in with SEC. Ether Delta guy claimed that we are DAO, so we now have CEO, but SEC was like, shut up, you are the CEO, so you're the one who goes to jail. So he gotta do all the work for the SEC. So, and that's my question: if a government like North Korea or China can do everything, right?
Well, wait, what's the question?
Yes.
There's two different things you mentioned.
Yeah.
The thing that happened with Ether Delta versus forcing people to reveal their view keys. Those are different things. Because one is the CEO of the company that was operating Ether Delta, and the other is the end users who are users of a crypto.
So what I'm trying to say is this whole crypto scene is trying to make a whole new, different aspect of business or whatever. But so Ether Delta claimed that they are DAO, but SEC was like, no, you're not, and that's it. So Zcash or any other anonymous cryptocurrency is trying to build a fully anonymous cash system. But if a government come up with a law that can enforce someone to reveal his view key, and what can we do in
Well, I mean, so China came up with a law to ban cryptocurrency exchanges out of China. So what they all did was move to Singapore and Hong Kong and whatever, Malta. I don't know. I don't have a very specific answer. I think it's an interesting question. And I think we can learn from observations like China, India. Different countries are trying different kinds of laws, so we can see what happens in those different countries.
Oh, I have a question regarding the view keys. I guess it's kind of a new territory, so I'm not quite sure. But in terms of U.S. regulations, are view keys considered as something that, does that fall into the freedom of speech or property? Because property can be seized with a warrant, but technically your thoughts, you don't have to say something that's incriminating against you. So do you know how that would fall into? Because I feel like it's a whole entire maze.
Okay. Law is really complicated. Law is way more complicated than cryptography. The full answer is that there's 4 or 5 different sort of parts of law in the United States that might apply. Everything I was talking about here was financial regulation of financial institutions, which is a different part of law in the United States versus property versus freedom of speech, which you were talking about. Okay, so we can analogize it to the current state of the art, or the current state of the law in the United States with being able to unlock your iPhone. Did you know that in the United States, the police can force you to put your thumb on the iPhone button to unlock it, but they can't force you to tell them your PIN code.
Exactly.
Because in the United States, your thumb is like property and your PIN code is like testimony. It's not freedom of speech technically. It's the Fifth Amendment right not to be forced to testify against yourself. So that's why they can't force you to tell them your PIN code. Anyway, so that's just a weird fact. The police can force you to unlock your iPhone if you've got fingerprint unlock, but not if you've got PIN code unlock in the United States. So now we depart into pure speculation mode. I suppose if you memorize your Bitcoin private key or your Zcash private key, then the police can't force you to tell it to them, according to that precedent. But if you write it down, then they can force you to hand it over, I guess. But I'm not going to memorize my Bitcoin private key because I'd be terrified that I'd forget.
This might be a silly question. As far as I know, Zk snark needs a trusted setup, right?
Oh yeah.
Yeah. So I heard trusted setup needs a lambda, which is a kind of the process of creating a master key of the network, right? So what was the process of generating your lambda key of Zcash mainnet?
Okay, that's not a silly question. That's a great question. So the thing is, the zero knowledge proof technology we use to allow these encrypted transactions to be validated, to be put into a blockchain, that thing requires this setup process, and it's hard to explain. There's this cryptographic number that could exist, which we decided to call that the toxic waste, because we decided to set up the system without allowing that number to ever come into existence. So our metaphor was, we're going to set up our factory in such a way that instead of the toxic waste getting generated and then we have to figure out how to safely dispose of it, instead we're going to keep all the toxic waste precursors separate from each other so the toxic waste never gets generated in the first place. So what we did was invented a cryptographic process called a secure multi-party computation. And we've done this twice now because Zcash had a 1.0 version that launched in 2016, and then we upgraded the cryptography and had a 2.0 version that launched last year. In the first one, there were 6 parties that each made one of the precursors, and it would have required all 6 of the precursors to come together in order to generate the toxic waste.
So it's kind of controlled by a small group. I mean,
yeah,
6 precursors.
If the 6 different people who were running the 6 different computers all colluded with each other, they could bring all 6 of the precursors together to generate the toxic waste. And we didn't explain yet, the thing about the toxic waste is it can, if you know the toxic waste, you can forge the zero knowledge proofs. You can make proofs of things that aren't true. And that ruins the security of anti-counterfeiting. That allows you to counterfeit Zcash if you know the toxic waste, but it doesn't allow you to violate anyone's. You can't decrypt anything with it. You can just forge new transactions. So it can't violate anyone's privacy, but it can forge counterfeit Zcash as much as you want. So in the first version, there were 6 people who each had one of the 6 precursors, and I was one of the 6. So me and the other 5 people all claim that we did not conspire with the other 5 to generate the toxic waste, and instead we destroyed our precursor before it could come into contact with any of the other precursors. And then that was the first version of Zcash, and then we made a new version last year, and it was an open invitation, so everyone on the internet could join and could manage their own precursor, and there were about 100 or 80 or 100 people who each did that. So it would require that all 80 of them conspired with each other in order to bring all 80 of the precursors together to generate the toxic waste for the new version. And actually, can you go to the next slide? This is my bonus. Do we have the bonus slide? Can you hit reload? All right, it's not important. There's a slide somewhere. No, it's just not down there. There's no bonus slide. You might have to hit reload, and you might get a bonus slide after you hit reload. No? All right. There are, it's possible to invent, how do I put this? There are several new zero-knowledge proof systems. So the one that those scientists from MIT and Johns Hopkins and Berkeley and Technion and all those other universities, they invented a zero-knowledge proof system in about 2013 or 2014, and that's the one that we used in Zcash. And that one has this toxic waste problem. And since then, there's been several new zero-knowledge proof systems invented. And some, like, they're very new. Like cryptography, Zcash is already very cutting edge because it's the first commercial large-scale application of this zero-knowledge proof technology. And I'm really proud of the fact, I'm pretty sure that the fact that Zcash launched and didn't completely fail, like didn't completely fail and get hacked and whatever, and the fact that people value it and it's worth real money, I think that's probably a good part of the reason why zero-knowledge proofs are so widely used. Like, I think 2 days ago we saw that MasterCard announced that they're using zero-knowledge proofs for an identity system with a bunch of banks. And whenever I see that kind of thing, I'm pretty proud because I don't think that was going to happen if we hadn't done this in 2016. But since 2014, when the scientists came up with that, several different scientists, including some of our own scientists, have come up with new improved zero-knowledge proofs. And the new ones usually have better toxic waste handling. Like the really great ones have no toxic waste at all. I call them toxic waste-free cryptography. But those ones are too inefficient to put into a cryptocurrency today.
You mean ZK Starks and Bulletproof?
Yeah,
things?
ZK Starks is still working on it. So, so the slide that we're trying to load has ZK Starks and Bulletproofs. Those are two of the newer ones. And this is so exciting. The tension is building. Are we going to get... Nope. ZK Starks, so the ones that we use in Zcash are called SNARKs, S-N-A-R-K. And since then, some of the Zcash scientists and others invented, well, actually it was all Zcash scientists, but since then, some of our Zcash scientists invented an improvement called STARKs, S-T-A-R-K. And one of the advantages of STARKs is that they're toxic waste-free. But Starks require like 50,000 bytes per proof. So we can't really just include a 50 kilobyte proof string in every transaction, because transactions currently are like 2 or 3 kilobytes, and multiplying them by up to 50 kilobytes, I think it might like clog the network, you know? So that's not quite good enough. And then bulletproofs are super great. They're also toxic waste free. They're based on some nice old-fashioned cryptographic assumptions. They boil down to discrete log type assumptions, which is great. And they're fast, or they're short. They're like 1,300 bytes, I think, maybe per bulletproof. Is it there yet? Oh boy, oh boy, oh boy. Is it at the end? I guess it's not. But bulletproofs take way too long to verify. Like 1,000 milliseconds to verify a typical proof. And that's too long on a blockchain because we need to have fast verification time so that all the other miners can start mining on top of the new block. So that's kind of frustrating. Like, it's almost there. And then the really exciting thing on this slide that they're working on is the very latest invention from some of our scientists from Zcash is called Sonic, S-O-N-I-C. I guess it's probably named after Sonic the Hedgehog because it's fast and small or whatever. I don't know, and cute and hairy. Sonic is small enough and fast enough for a cryptocurrency, but it's not perfectly toxic waste free. But it's kind of like, I don't know the brand name for this. Maybe you can help me brainstorm. But in Sonic, there's a setup process you have to do to prevent toxic waste. But you can update the setup anytime so that the new person who came along and updated it, as long as they did not collude with everyone who came before, then there will be no toxic waste. So it's updatable. So like you could imagine maybe in a future version of a cryptocurrency like Zcash, like every miner, whenever they mine a block, they update the setup parameters. And then the only way there could be a toxic waste forgery is if this new miner was in cahoots with every other miner who ever came before. So it's updatable. That's cool. And the other cool thing about Sonic is that it's so-called universal, which means everyone can use the same parameters to prove any proof system. So like MasterCard and their new identity system, they could use the same parameters that were generated by the same miners. And like MasterCard could also update it. And so then everyone would know all of the miners plus MasterCard would all have to be in cahoots in order to backdoor this. So like everyone in the world can use the same proof system. And it's very efficient. So we could potentially actually use it in Zcash. All right, I could go on about this stuff all day. That was the longest answer per question. Oh, hey, yeah, look at this. This one, next. Next. Snarks. Way to go! Woo! Snarks. You have to do this ceremony I described. We had 6 people in the first one. We had 80 people in the second one. It takes 2.5 seconds to generate a new proof in Zcash right now, which is not great, but it's not that bad. Like if you have your phone and you say, I'm going to send you some money, it takes 2.5 seconds. That's okay, I guess. And all the miners and verifiers, it takes only a few milliseconds for every transaction. And that has to be really short because a block could have like thousands of transactions in it, right? And you have to verify a block really fast so that you can mine on top of it in the mining network. And the size of it is very, very small. Snarks are super tight in the proof size. So we add in another couple hundred bytes into every transaction for this proof. And now Starks are super great. Oh, I have to really clarify. Like everyone's taking pictures of this. So like whenever you post this on social media, you have to say, Zooko's not saying that these are bad. They're good, but they're good for other things than a per transaction zero knowledge proof cryptocurrency, right? Like Starks are potentially really awesome for some kind of DEX or off-chain accelerator, because if you can spend 50,000 bytes, 50,000 bytes is fine for, like a web server or a DEX or something, in which case Starks might be perfect for that. You just can't put 50,000 bytes in every transaction on in a Bitcoin-like blockchain. And similarly with bulletproofs. Bulletproofs are awesome. The only problem with them is it takes a whole second to verify a zero knowledge proof. So that's great for your like MasterCard identity program or your DEX or lots of uses, but you can't do this for every transaction in a Bitcoin-like blockchain. And this is the new stuff that our team is currently working on. I'm really excited about it because, okay, so it takes 5 seconds instead of 2.5 seconds to send a payment, and that's like mildly annoying, but it's probably fine. And then these two numbers are fine for a Bitcoin-like blockchain. So I'm excited about it. And like I say, it's updatable and universal, so it could turn out that like more and more people start using it and relying on it and updating it, and it becomes like the widely used standard zero-knowledge proof some decade from now. That was satisfying. Thank you for doing all that work to get this. I really... Hey, can we see the next slide? This is the summary, and again, this is only for Zcash. It's very different if your use case is MasterCard or DEXs or other things. But for Zcash, this one works okay, except the one-time ceremony is really annoying because like you can never prove that all 80 of the people weren't like all fakes. You know, like the whole thing was staged, especially to people who come later. Like the people who were there at the time are probably convinced that the other 79 people were legit. But now, a year, 2 years, 10 years later, it's going to be harder and harder to convince people to trust it. So that's frustrating. Yeah. So anyway, this is great, except for this part. And this, I think, is probably doable, like practical for Zcash's purposes. And these two are great for other things, but impractical for Zcash's purposes. Yeah, this is my favorite slide. This is the new stuff. We've never talked, like this has just got published in the science literature 4 weeks or something ago, and we haven't really talked about it much yet, but it's exciting. So we're going to talk about this at Economy.
I have one more question. I might be missed it. What do you mean by universal? Is it kind of Aztec protocol?
Universal's like this. What's the question?
Aztec protocol. Is it? Are you gonna make some application platform like Ethereum for ZK snarks?
Well, we could, but that's not exactly what I mean by this. What I mean is that for the snarks and the bulletproofs, I don't remember about. I think Starks are universal as well, actually, but it doesn't really matter so much since they're toxic waste free. But for snarks, if you say, oh, Zcash is using snarks and it works really well, I want to use snarks for my DEX or Aztec protocol or my MasterCard identity scheme or any other purpose, you can't use the parameters we generated with our 80 people for your new thing. The parameters we generated with our 80 people, the only thing they do is Zcash payments. So you have to do your own ceremony, and you have to convince everyone that your ceremony doesn't have toxic waste. With Sonic, if we do a ceremony, like if we build it into the miner, so after a year there's been like 10,000 different miners have added to it or whatever, you can then use that same parameters for your DEX or your Aztec or whatever else. So then you inherit the toxic waste mitigation from the ceremony that everyone else does. Anyway, by the way, yeah, you could do, to totally tangent, because I'm getting excited about this crypto stuff, your question was, are we going to do like Ethereum style smart contracts or whatever? Well, we could. There's this really great technical architecture that some of our scientists have published. One version of it's called ZEXE. It's a science paper that some of our scientists wrote. And what it says is, you know how in Ethereum, the way you get your smart contract run is you distribute a copy of your smart contract to every miner, and then you show the inputs, and then every miner executes your smart contract with those inputs, right? And then they agree with each other on what the output was, and then that's the result. Well, this is really, really inefficient to have every miner executing the program. There's like, if there's 10,000 miners, that's like 10,000 computers all running the same program just to make it execute once. So ZEXE says, how about this instead? I'll run the program myself, and I'll generate a zero-knowledge proof that this is the output. And then I'll send that zero-knowledge proof to all 10,000 of the miners. And now they'll run the zero-knowledge verifier. But the zero-knowledge verifier, like we said earlier on the previous slide, it takes like 7 milliseconds. So it's much more, yeah, 7 or 9. So, I mean, even if it took a whole second, it's, I don't know if a whole second's a long time, but if it's 7 milliseconds, it's much more efficient than having all the miners execute all the programs. So you get a lot more scalability, and you also get more privacy, because then you don't have to tell every miner what your program is or what your inputs are in order to execute it. So that's really cool. But we're not planning on adding that to Zcash anytime soon. Because, okay, hold on. It's time for a poll. How do I put this? So my hypothesis is some people prefer Zcash. How do I put this? Some people prefer Bitcoin over Ethereum because Bitcoin doesn't have scripts, doesn't have smart contracts. So how many people would use Bitcoin less if it added smart contracts? Raise your hand. There's 2 people who would use Bitcoin less if it added smart contracts. Okay, how many people? 3. 3 people would use Bitcoin less if it added smart contracts. Okay, how many people would use Bitcoin more if it added smart contracts? 3. So wait a minute. What about you? You would use Bitcoin the same amount if it added smart contracts. You don't care. And that's the majority. Like what about you? You didn't raise your hand. Yeah. Mm-hmm. Mm-hmm. I agree. Okay, so that was really interesting. So we've been talking about whether we should add smart contracts to Zcash. Well, I'm opposed. It sounds like really hard, and I'm not convinced that it would increase the better usage more than it would decrease usage due to being more complicated. So. But instead, I want to make Zcash scalable, which nothing else, including Zcash, currently is. And I think it would be a lot harder to make it scalable if it had smart contracts. I think I can see how to make it scalable when it's just simply payments.
When you say smart contract, you mean Turing complete?
Yeah, I mean like general purpose smart contracts, so you can like code up new things and run them. Yeah. Hey, we're totally going way over the 8:30 plan. But that's fine. Does anyone want to keep going and ask more questions? Uh-huh. Yes. 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 Oh, that's a lovely question. Do we have all those slides here? Can you go back? The question was, we recently made a major upgrade called Sapling. This is Sapling. And this was the first version. This was version 1.0. Okay, everybody's allowed to go if you have to. Thanks for coming. But no, seriously, you're allowed to go because it's like 8 something. I've lost track of time. So this was first version with the 6 participants in the ceremony and the first version of the cryptography. And it took 37 seconds. So you go to pay someone, and then you have to just sit there and wait for like a minute. And that's a long time. That's annoying. And so we worked for more than a year, and we came up with this new version called Sapling, which reduces the time it takes to 2 seconds. Now, there's a bunch of slides that are not in here that show the answer to your question, which is, how do we do that? Did it involve a new elliptic curve or what? And the answer is involved about 4 different cryptographic improvements that were sort of complementary or tied together. One of them was a new elliptic curve. There was a new implementation that we wrote from scratch in Rust that was faster. There was a new secure hash function inside the circuit, which was faster. And then there was a thing where you only use one coin most of the time instead of merging two different coins together every time, if that makes sense. I think those are the main 4 factors. And several of those factors are reusable for other zero-knowledge proof implementations out there. Like I said, there's a lot of different companies and new technologies that people are building using zero-knowledge proofs, and a lot of them are using the new Rust implementation we wrote and the new elliptic curve we invented, because those are reusable for anything, not just for a payment system. The other 2 are techniques that are more specific to payments, but might be useful for other things too, especially the secure hash function. Does that answer your question? Is there a question? Wait, who? Is there someone who hasn't, or who are you gesturing at?
Yeah, in the long run, how do you think Zcash would differentiate itself from the likes of Dash or Monero?
In the long run, well, our intent is to differentiate ourselves just by good execution. Like we have this. There's a whole bunch of stuff I didn't describe at all, but Zcash has a nonprofit foundation that supports it, and it also has a for-profit company, and I'm the CEO of the for-profit company. So there's these 2 different institutions that are separate from each other, and they both have funding from the Zcash blockchain. And so our strategy is just to do a good job of improving everything about it. So we did this protocol improvement because this 37 seconds was a real pain in the butt. And we're making like wallet user interface design, and we're going around like doing marketing and business development and getting Zcash added to all of those business partners whose logos I showed you earlier. So I think of the long term as more of a matter of execution than of features. You see what I mean? Yeah, the times. Can you go to the next slide, June? These are all on some 64-bit Intel AWS server, I think. I think it was an AWS server, but they're all 64-bit laptops. But it's actually not that much different on like a 64-bit ARM chip. Only maybe a factor of 2x or even less, because ARM chips are really efficient now in terms of core computation like this. And this is all just computation bound. It doesn't require interesting I/O or anything. So the question is, beyond competition from Dash and Monero, also other crypto coins can adopt. What'd you say? The technology, yeah, or other technologies. Like I know Litecoin announced that they were going to add Mimblewimble, for example. That's an example of other coins adding privacy technology. Like I said about HTTP versus HTTPS. So for the first like 10 years, it was this huge struggle between the American like Silicon Valley and a bunch of cypherpunk activists versus the government. And then for the next like 10 years, it was this technological struggle to deploy and upgrade to a giant distributed system. And now it's just standard and everyone uses HTTPS all the time. And almost no one ever uses HTTP, right? So I predict that in like 20 years or so, there won't be any unencrypted blockchains. They'll either have figured out how to painfully back engineer some kind of security on top, or they will have gone out of business. But anyway, so your question was, is that like a competitive threat to Zcash? And it's really just the same answer. Like I don't think Zcash's competitive advantage is we have this one feature. I think Zcash's competitive advantage is we're pioneers who've successfully implemented and deployed novel, sophisticated technology multiple times, and we're continuing to do so. So I think you shouldn't think if you're trying to predict the future, which I don't really have to do so much. I just have to work really hard on improving the present. But if you're like a long-term investor or whatever, or a science fiction writer, you want to predict the future, I would advise you don't think in terms of features, think in terms of like team and execution velocity and like business stuff, like the funding cycle. Because basically, like, why do we think Ethereum is going to add private transactions faster than Zcash is going to add smart contracts? Well, it could go either way, but if you're just thinking in terms of Zcash being a feature, then you would say, oh, obviously it's just a feature, so Litecoin will add that feature. But if you're thinking of it as being an evolving like community and development team and system, then it's an open question of which community and which development team is going to execute better over the next 10 years. Yeah. Well, that was a generalization about all governments in general, starting with my experiences in the internet industry in the 1990s. Recently, I've actually been pleasantly surprised at how governments have been catching up on the topic of blockchain and cryptocurrency faster than I expected. Like, it's only taken them 10 years since Bitcoin was invented to get to where they are today, which is not bad. I really didn't like New York's position that every entrepreneur has to ask them for permission before doing a thing. That's like, that's not the best way to do it, but at least they have proactively engaged and made regulations. So that's helpful to have them, if you see what I mean. Well, our company just makes the technology, like publishes software, right? And then a bunch of other companies, like all the ones on that slide full of logos, implement it and make it available to customers and make money off of it in various ways and stuff like that. So it's the jurisdiction of all those companies that's really important. And a lot of them are in the US. So it's really important that US regulators have been so like understanding of the advantages of blockchains and encryption. Finance is in Malta and it supports Zcash. Almost every exchange supports Zcash in all the jurisdictions except for China and India where they all went out of business. Does that answer your question? Yeah. Oh, yeah, China and India are the most backwards. Yeah, honestly, I mean, yeah, I've spent a lot of time with US, or my company has spent a lot of time with US, UK, EU, Japan, Singapore regulators. And I visited with the Chinese regulators, but they did not listen to me. Last call for questions. Thanks, y'all. Thank you for coming.